Okay, let's take a look at our problems we did not complete on Friday. You can see here's our first one. Mean time to complete a certain psychology exam is 34 minutes with a standard deviation of 8. What is the probability of a student taking more than 28 minutes? So here we will first calculate our z-score. Again, our z-score is our value, which is 28, minus our mean, which is 34, divided by our standard deviation, which is 8. If we do the calculator work there, we'll get a negative 0.75 as our z-score. I'm going to take that z-score to my curve. Again, putting 0 down the middle, negative 0.75 here. It says more than, so I'm going to shade above. As we go to the table, we will find a 4-digit number that goes with negative 0.75 of 0.2266. Since our table measures the area to the left, we will subtract that area from 1 to get our area to the right, and that area is 0.7734. So the probability of taking more than 28 minutes is 0.7734. Moving on here, between 15 and 28 minutes, we obviously already have a z-score for 28, but we do need a z-score for 15. So 15 minus 34 divided by 8 gets us a z-score of negative 2.38. I will place both of those z-scores on our curve this time, putting the 0 right down the middle. We'll have negative 0.75 closest, and then negative 2.38 over here. It says between those two, so we already have a z-score or an area for 0.75, which is 0.2266. We'll look up negative 2.38 in the table, and that value is 0.0087. When we subtract those two to find the area between, the probability of taking between 15 and 28 minutes is 0.2179. Continuing on here, moving our page down a little bit so we can see a little bit better, between 28 and 41 minutes. Again, we already have that z-score for 28, so we'll calculate one for 41. Our z-score is 41 minus 34 divided by our standard deviation of 8. That gives us a z-score of 0.88. Placing that along with a 28-minute z-score on our curve, continue to put 0 down the middle. We'll have negative 0.75 on this side, 0.88 on this side. You can see here we want the area between those two, which means, as kind of a guideline, I would suggest we look up 0.88 first. That number is 0.8106. We'll subtract the area that we've already found for negative 0.75, which is negative 0.2266, and that gets us 0.5840 as a probability of taking between 28 and 41 minutes. Last problem is worded a little bit differently. If 100 students took the exam, how many should finish in less than 30 minutes? We'll go ahead and find our probability and then convert that to a number of students when we're done. So to convert that to a probability, the first thing we need to do is find that z-score again. Our value is 30. Our mean is 34. Our standard deviation is 8. Gives us a z-score of negative 0.5. On our curve, negative 0.5 will be on the left side. It said less than 30 minutes, so we'll go shade to the left-hand side. If we look up negative 0.5 in the table, we'll find a 4-digit number of 0.3085. This time we don't want the probability, we want how many. So of our 100, 30.85% take less than 30 minutes, or a total of 30.85, or about 31 students. So there is the first set of problems, just as kind of a refresher course on what we did on Friday. We have one more, And here it is. Teacher gives a test, and the results are normally distributed with a mean of 36 and a standard deviation of 5. Teacher wants to give the top 10% of the class A's. What should be the cutoff for an A? Here, because of the percent that's given here, that is a value under the curve. We're going to work backwards from our curve, putting our mean 0 right down the middle. Remember, that mean is the same thing as our raw score, our raw mean of 36. I hope we would all agree that the top 10% of the class is going to be on the right-hand side. So this area in the far right-hand part of our curve is 10%, or a decimal of 0.1000. Keeping in mind, as we work with our table, the table E from our book measures the area from our z-score over to the left. So the area to the right is 10%. That means the area to the left is 90%, or more specifically as a decimal 0.9000. So we go inside table E, find the four-digit number closest to 0.9000. I believe that number is 0.8997, and that would get us a z-score of 1.28. So my z-score is 1.28. Remembering our z-score formula is z minus our value, or equal to our value minus the mean, divided by the standard deviation. Well, we just found the z-score. We don't know the cutoff for A, so we're looking for the x, but we do know the mean is 36, and we know the standard deviation is 5. Just walking through this step by step one more time to double check our algebra skills. To solve for x, I would first multiply both sides by 5. That would get me x minus 36 equals, so we have a 40, a 10, 11, so a 6.10, 6.40, sorry, and x then is going to equal a cutoff score of 42.4. So our cutoff for an A would be 42.4. And that should give us a good refresher of our applications of normal distribution. I'll go ahead and write it up here. We're working on pages 325 to 328, I think is where we already had 2 through 12 even assigned on Friday. We'll go ahead and complete this section. 14 through 38 even is the remainder of our assignment that we did not get on Friday. The answer keys are up here on the front desk and also on the overhead. Use those as necessary to check your answer, but we should be able to have that done and ready to go for class tomorrow.